Air doesn't normally conduct electricity, but if enough charge builds up in the cloud, it can jump the thousands of meters to the ground. But what exactly triggers that discharge remains one of nature's greatest mysteries.
That's an active area of research, knowing at what point that is. It's actually very hard to take measurements of lightning within storms, and that's something that we're still working on.
The team needs that cloud-to-ground discharge of electricity if they're to achieve their mission. So far, they've chased storms for hundreds of kilometers.
Is there another one?
Yeah, big one right there.
God dang it.
They've avoided getting struck by lightning
Be careful, lightning. Just get in the car.
and survived extreme weather. They've even captured stunning cloud-to-cloud lightning on camera.
That's beautiful.
But they still haven't got what they came for. Super slow motion images of iconic cloud-to-ground lightning bolts.
Three, two, one, go!
But today, the weather balloon is picking up some promising data.
We can see the temperature's going down. The environment looks really primed for storms, and we're already seeing some really nice convective storms here.
But time isn't on their side. The storm season is almost finished for another year. They're heading for a storm 80 kilometers away. The clouds are towering above them over 10,000 meters high, and they look laden with water and ice. Could this be the electricity generating machine they've been looking for? Will it produce the elusive cloud-to-ground lightning? And if it does, will they be able to capture it? The super slow motion cameras are soon ready to catch an event that usually lasts just a fraction of a second.
I've got the camera running at 100,000 frames a second right now. And I do hear a little bit of thunder in the background.
Suddenly,
Oh! Oh! Oh, did you get that? There were 3 of them.
Got it.
Dustin thinks he's captured something.
Oh my God. That is amazing.
Go, do it again. I want to do it again.
Do it again, do it again, do it again.
Do it again, do it again.
In real time, the lightning bolt is just a flash. But Dustin's footage reveals the cloud-to-ground strike creates several pathways through the air.
That was badass. So it was the first time I've ever seen lightning like at that speed and like that resolution. It was insane. It was unreal.
When one of the pathways reaches the ground, all the electricity is discharged. And with nothing left to drive the other pathways, they vanish.
That stuff you almost don't see with your naked eye that bright. You see a quick flash and you have no idea it looks like that. That's amazing. Oh, that is a good bolt.
It's a fantastic first result,
Sad I was switching lenses.
and Jeff's struck it lucky too. His camera records much slower than Dustin's and reveals even more detail.
Oh, nice.
Nice.
Very cool.
The iconic lightning bolt we see with the naked eye is in fact a vast electrical charge traveling upwards from ground to sky.
I've never seen anything like that before.
That's the part that hurts. You don't want to be around that.
The moment the team feared would never happen is finally here. It's showtime.
Oh! Oh, God! Oh!
Got it? Oh, nice.
What a great spot.
I got
Let's
that one.
go! Oh, that's a good one.
But they haven't completed their mission. And as day turns to night, there is one last image that the team is still desperate to capture.
We'll drop it in this way first.
This is just the opportunity Jeff's been waiting for, to use his light-splitting filter.
Oh yeah. Oh yeah. Yeah, that looks good.
It's the first time Jeff has tried it on a color slow motion camera.
Wow, that's really awesome.
It reveals yet another surprising secret that can't be seen with the naked eye. The vivid colors that make up the white flash.
So you can see the big return stroke over on this side, and then the spectra is over here.
Jeff can use the different amounts of each color to calculate the temperature of each individual lightning bolt. The more blue, the hotter it is.
Say 25 to 40,000 degrees Celsius for the return stroke.
Well, that was incredible. And I love seeing all that. Oh!
Oh!
Oh! That was good! Holy! Nice!
Success! The team has achieved everything they set out to do.
Whoa!
Oh, nice. Oh, wow.
Boom!
Oh, that looks great.
Their mission is complete,
This is a great last night.
Awesome.
and they've given us a ringside seat at the greatest display of electrical power on our spectacular Earth. And at Nazaré in Portugal, that interaction between the ocean and the shape of the seabed is crucial in the creation of the megawaves that our team hopes to film. Here, the waves are boosted by a feature unique to Nazaré. A feature which makes the monster waves notoriously erratic.
Unpredictability of the waves is definitely one of the toughest things about Nazaré.
For 20 years, João has been involved in a project using sonar to discover more about the mysterious underwater landscape off Nazaré. He regularly works on board the Portuguese Navy's research ship, Dom Carlos.
Vem cá, senta aqui.
Captain of the ship is Commander Barruquero.
Hi, João. What are
Hello.
you seeing?
Hello, Commander. How are you? Well, you just...
Sailing parallel to the Nazaré coast, at first, the sonar reveals that much of the seabed is level and shallow. But then it shows an abrupt change on a vast scale.
So in the very short distance, the bottom has increased from 100 to now almost 250 meters depth.
The seafloor is dropping away dramatically.
So we are navigating over an area that seems like a steep wall, and we continue to decrease this. 300 meters.
Still increasing.
Still increasing.
Their research is revealing in more detail just what's hidden beneath the waves. It's a 230-kilometer long canyon that runs from far out in the Atlantic towards the coast of Portugal. In places, it's 3 times as deep as the Grand Canyon, the deepest point being over 5,000 meters down. And it ends just off Nazaré. It's the position and size of the canyon which are key to the formation of the megawaves and what makes them so dangerous.
There's waves coming from different angles colliding, which also, you know, that creates those ginormous waves. You'll see waves coming up the beach, coming down, crossing. It can be frightening.
The direction of the waves changes as they hit the edge of the canyon. This makes them collide with other waves. Where they cross, they merge to create even taller waves.
The energy of these two waves combines, and so this explains why a 10-meter swell arriving from offshore can increase to a 20-meter wave or more.
Andrew knows only too well how deadly the waves created by the canyon can be. Because in 2017, one of these waves nearly killed him.
It was a real good peak. Had that energy from the canyon. I was going to try and position myself to put myself inside the wave now, which is every surfer's dream, to get inside the wave, big barrel, and the wave just changed shape.
Andrew was flung 10 meters into the air by the immense power of the wave.
It seemed like eternity. You know, it must have been like a split second. It was like jumping onto concrete. I knew instantly that I was seriously injured.
A rescue team managed to get him out. Andrew had broken his back. Amazingly, only 6 months later, he was back on his board.
All good? Yeah.
Now, Andrew is going to put his life on the line once more.
Hang on, Sergio, you just need to pull out the things.
Today, the canyon is producing waves of about 10 meters, nearly as tall as a 3-story house. The team decides to put their filming plan to the test in preparation for the larger waves, when and if they arrive.
I think it's a good thing to be nervous. It means you're respecting the ocean. Definitely don't want to go out there cocky, even when it's not even that big.
With the stakes so high, Laurent and Andrew are tailed by a safety team on jet skis. If they get hit by a wave, the rescue team will only have seconds to pull them out before the next wave breaks and possibly drowns them.
It's looking good.
Laurent plans to film from the side of a wave, as close to the breaking crest as he can get. Too close, and he and his pilot could get thrown off the jet ski. To survive Nazaré's giant waves, they'll need to keep their wits about them.
It's complicated because like every big wave in the world has a channel, right? It's like it breaks and then here it's flat and here it's flat. So you can always hang out in the channel and get the shot. And here it's not at all like that. It's coming from all angles.
Okay, drone's going up.
With Laurent out on the water, fellow cameraman Peter Keith launches his high-tech drone to capture a bird's-eye view of the wave.
Whoop, that was quite close to the water there.
He wants to fly right along the crest of a wave as it breaks.
Oh man! I don't believe it.
He's got too close and lost his drone.
I was right at the end of the flight as well.
It's not going well, and things don't get any better. Out in the thick of the waves, Andrew is towed out by a jet ski, so he's in the best position to catch the next one. Although the waves today are not huge by Nazare's standards, their size and the choppy surface is making surfing and filming difficult.
Almost lost it, I hit a bump.
The camera fixed to Andrew's surfboard has shaken loose and sunk.
I think that's the first wave I've taken on the head this season.
It's back to the drawing board. They've had some powerful lessons on how difficult filming in these treacherous waters can be. And today's waves were only 10 meters high, half the height of the mega waves they hope to capture, if they eventually arrive. On land, the camera crews get into position. Out on the water, Laurent lines up to get the best shot.
Let's go.
And Andrew is ready for action.
This is it, man.
Some waves are now over 22 meters high. The mega waves have arrived. From the land, the team captures stunning shots. From the air, an amazing bird's eye view. On the water, Laurent is in the perfect position to film the glorious moment a gigantic wave breaks.
This was a big one. This is a big swell, a lot of energy, and yeah, it's a different beast.
And finally, Andrew surfs the sheer face of a giant wave at over 50 kilometers per hour. The team has got everything they set out to film, and Andrew's onboard camera has got some extraordinary shots.
Who would have ever thought that you could get that close to waves that big? That was the biggest wave of the day.
They have caught astonishing images of the biggest waves on the planet. Right from the heart of the action. Mission accomplished.
Actually being in the ocean when you're seeing the biggest waves in the world breaking, like, It's amazing.
Nazaré is the eighth wonder of the world. To witness these waves from up front row like we do, it's an honor.
The team has given us a ringside seat at one of the greatest displays of the ocean's raw power anywhere on Earth. But here in Guatemala, it's the collision of tectonic plates deep underground that plays a critical role in the team's mission. They're hoping to capture Fuego's next violent nighttime eruption. But much to the team's frustration, there's little sign that a major explosion is imminent.
Getting quite a few shots of some small eruptions. It's a case of just perseverance and keep on fishing, and one of these days we're going to catch one.
Beneath Guatemala, where two plates collide, oceanic rock meets continental rock. The oceanic rock is pushed downwards into the hot interior of the planet, where it melts. This newly created molten rock is less dense than the magma around it, and below Fuego, it slowly rises to the surface, eventually erupting.
What we're here for is some really good, large, explosive eruptions.
They could happen at any moment, or not at all.
Is that blast position, or is that where it's sitting right now?
The team knows that one clue that this big eruption is about to take place lies within the crater itself.
Slightly above the summit, looking at it from here.
Today, they are going to attempt the first part of their mission: to place a camera right on the rim of the crater to look down into its scorching heart.
Getting to see right into the crater would be amazing.
They are going to be looking for how much loose rock has accumulated and any sign of movement. This could mean a big explosive eruption is due any day. Duncan is going to use a remote-controlled camera he's built for the job. The only way to get it close enough is to lower it into position using a drone he's specially adapted. It has to be powerful enough to cope with the thin air at Fuego's summit, nearly 4,000 meters above sea level.
So we can test the camera.
It's the first time anyone has ever attempted this.
What we're trying to do here is completely new and innovative. We're trying to place these cameras right inside the crater of Fuego so that we can get angles that have never been seen before.
Duncan has spent 6 months designing and building the drone and crater cam.
Yeah, this camera's still good.
It's very nerve-wracking because you know that if there's a blast, the aircraft gets destroyed and you can't try the experiment again.
He only has one set of kit, so if anything goes wrong, there's no second chance.
But I'm just trying to talk myself out of this because, you know, because I know the consequences. If it goes off, we lose the drone. Should we go?
Yeah, I think we just go. Okay,
sounds good. Taking off.
Duncan's crater cam is in the air. It's accompanied by 2 other drones to help him guide it into position. He wants to place the camera in exactly the right spot on the edge of the crater, so it's pointing down into it. And then get the drone away before it's destroyed by an eruption.
600 meters to go.
Duncan's drone only has 20 minutes of battery life. It's a race against time.
300 meters to go. So we're entering the blast zone now. If it goes off,
Yeah.
we're going to be knocked out of the sky.
Yeah.
They are almost in position above the crater rim. The landing site is only a few meters wide. And if the crater cam smashes into a rock, it will be destroyed.
Okay, coming down now. Is it down?
No, pull up. You need to be closer to the crater. About 3 meters closer to the crater.
Yeah. We're in the danger zone for far too long, but we need to get this camera down.
Yeah.
Okay, how far am I? Oh, Christ, I just hit the volcano.
You're right within the crater now. You're right above the vent.
Duncan's now drifted right above the crater itself. And the volcano could erupt at any moment.
Eruption. Rise up. RTL.
Suddenly, lumps of red-hot magma hurtle towards the drone. It's undamaged, but the battery is now nearly flat. They have to abort the mission.
Into auto.
Coming home.
They got the kit out just in time.
So where we were hovering, those huge boulders have just come out.
Yeah. How can we zoom in?
Wow, that's crazy. Yeah, if you hadn't said there was an eruption coming, we would have still been there. And there's a reason why it hasn't been done before.
This part of their mission has failed. It takes far too long to position the camera using this system. And it will take months to redesign. The challenges of trying to fly drones in such a hostile environment have suddenly become all too apparent. But even though they couldn't drop the camera on the crater, they did capture a unique view inside it. And that's given them a clue that a big eruption could be about to happen. They send up a recce drone to double check.
And the crater's really full with all this material that is built up from explosions.
Yeah, a working hypothesis is that the volcano erupts much more violently when the crater is full.
With the crater this full, the big eruption the team is hoping for could be imminent. One with enough energy to blast red-hot molten boulders the size of cars hundreds of meters into the air.
I mean, look how full it is. Right?
Yeah,
all
it's
of this stuff.
really full.
But for that kind of large explosive eruption, another crucial factor has to come into play. The minerals in the very rock itself.
Across volcanoes around the world, we have different types of rock that makes volcanoes erupt in more explosive ways.
The mix of minerals in the rocks beneath every volcano is unique and dramatically influences how each one erupts. The final part of their mission is underway. Peter flies his drone towards the crater and starts to circle the danger zone.
Okay, you're quite Yeah, you're quite
Getting
close
quite
there.
close.
So you're well within the ballistic zone there.
Definitely.
Okay.
Now, all the team can do is wait.
Go on, blow, man, blow.
And hope they are in the right place at the right time.
That is extraordinary.
Wow.
Just as they had hoped, Fuego's crater ruptures. The footage reveals that rocks from this massive eruption are traveling upwards at over 100 meters per second.
That's lovely.
Isn't it?
This blast has the same force as 10 tons of high explosives being detonated, and is by far the biggest eruption the team has witnessed.
Thanks, Fuego.
As day turns to night, all their hard work and preparation are finally paying off.
Get out.
Really good.
Over the next few hours, Fuego explodes. Not once, but again and again.
Look at that!
Look how high those ballistics are. 300 meters?
The high-definition footage shows the true size of individual molten bombs of lava.
I've never seen that much detail from an explosion like that. It is absolutely mesmerizing.
I've realized that ice is one of the most fragile materials you can find on Earth. At the base of a frozen waterfall, I always feel a little nervous. Oh, yes, the ice is nice here.
Maureen has reached the area where she wants to collect her first sample.
Okay, I get it. When hanging on a rope, drilling is a little more complicated. I'm always scared that I can slip on my feet and then, lose everything.
Here, the ice is white and opaque. She thinks this could be partially down to the type of crystals. But to be sure, she'll need to test her sample later.
Up. I'm going slowly. Okay, look at it. Good. Okay, nice.
Now, for the second sample.
Ah, mais c'est pas vrai. Ah, c'est dur de repartir. Guys, it's very nice.
The team has reached the second sampling site, the overhanging stalactites.
Up. Yeah, good. I'm very happy. We have a big piece of it.
Later, when they are safely down, Maureen sets about comparing the samples. She uses a polarizing filter that shows individual crystals.
This one is really nice.
Oh, that's really nice.
This sample from the lower part of the waterfall contains small ice crystals. This tells Maureen that the water probably froze quickly at very low temperatures.
So small grain might be coming from fast freezing.
In contrast, the sample from the highest section of the waterfall has much bigger crystals.
Nice color.
Yes. What is nice that we can really see the elongated grains.
It's likely these large crystals formed slowly, at temperatures only a little below freezing.
What I would expect on something like that is that we had water flowing down, so 0 degree water, and so it really freezes gently, so the grain could be long. Nice story?
Nice. Very nice.
Maureen's research is helping to build a picture of how these frozen waterfalls depend upon the size and structure of tiny crystals of ice, every one of which is shaped by the temperature at which they form. And that connection is universal. Whether it's the ice crystals that form in the frozen waterfalls of Switzerland in midwinter,